Hi there. This lecture talks about a particular concept which is known as mental models. So what I'm going to do in this lecture is just talk you through what we mean by mental models, just to help you to understand the concept of mental models and how we can influence them. So I'm going to introduce the concept of a mental model, and I'm going to explain the relationship between system design and user mental models, because it's when we understand that relationship we can understand more clearly what it is to influence mental models and why it's important to consider in cognitive ergonomics in design. So the first thing to realise is that mental models might not exist. They might not be a thing. But as with many other concepts that we talk about in this lecture, they're a useful concept to help us think about why we should design in a certain way and what our considerations should be. So the underpinning premise of a mental model is that it's an internal psychological representation of how something works. And that something could be a technical system. It could be the interaction between people and technologies. So normally, a mental model is a model of something that's dynamic in some way, that changes in some way. And it can be a model of how a system works, how different elements of the system are related, and what the internal processes are, and how they affect those components. The interesting thing about mental models is they tend to be erroneous, incomplete, unstable, and fragmented. We very often fail to design for the formation of a mental model, but people form them anyway, and the key reason why we care about mental models is we believe that an individual's mental model influences the way they behave. And people can have several mental models of a single system, and different models might represent different facets of that system. So one of the things I'm going to recommend you look at is this video. If you type in this particular code, it should work, and it will take you to a comedy show called Peep Show. It is a video that includes some swearing, so if you don't like swearing in a comedy show, then don't watch it. And the sort of scenario that is being portrayed is an individual who has an erroneous mental model about something we very commonly use in our household. So I'll give you a couple of minutes just to go away, and so if you want to pause this particular video, go away and watch the other one, and then you can come back to this video. Okay, hopefully that's given you enough time to come back and watch this video, and you can carry on. So I'm going to just talk a little bit about some examples of mental models. And I'll give you an example that we're dealing with right now. So I'm recording this lecture during the coronavirus pandemic. And one of the things that in the UK we're being asked to use is an app on our phone. And the app is being used to support the process of contact tracing and management of isolation. Now, it's very interesting when we think about our mental model of the app. So there's been an awful lot of thought that's gone into the design of the app to consider how we can support an effective user model, but we can see it's not always worked as well as it could have done. So one particular way in which the app has been considered is in terms of our data and data privacy. The app's been designed with data privacy in mind to try and reassure individuals that their data are not being shared, their personal data about their name or anything like that is not being shared. But people have been uncertain about whether that's the case or not. So this week there was a news story, and the news story said that the police were going to be using contact tracing information to follow up if they believed people were not currently sticking to the rules around isolation. And the response on social media was that many people, and I'll be honest, I even thought this myself, I had an erroneous mental model, said, oh, well, I'm going to delete the app. I'm not going to use the app anymore. I didn't delete the app. That was an example of an inappropriate mental model of what we thought was happening there. We equated the declaration that police were going to use contact tracing information as being that they were going to use information from the app. Whereas actually, the contact tracing system is a separate system to the app, and the app telling us whether we need to isolate or not. The app works on a basis of proximity, either with a particular location if we've checked into a location, or if we've been within 2 meters for a certain period of time with someone else who's got the app on and then subsequently reports a positive test for coronavirus. So in this particular case, there were 2 elements that we needed to understand. We needed to understand how the technology on our app worked, whether it used Bluetooth or global positioning, whether it was recording our data somewhere. All of those things played into our model of how the system worked. But we also had an inappropriate mental model of what the police were going to be doing, and the police were using the separate information around contact tracing in order to actually enforce the regulations around isolation. So very often we form a mental model in order to help us to understand and behave in a certain way. But if we get those mental models wrong, then we behave in a way that's not necessarily ideal for the overall system outcome or even our own personal goals. So this slide shows the relationship between the user's mental model, the system image, which is the thing the user interacts with, and the designer, because of course what the designer does is influences the user's mental model via the system image. So let's think about the user's mental model first of all. The user brings something to their use of a technology or system. They bring their prior experience, they bring information their colleagues might provide, they bring information they might have had from their training. They're influenced by the environment they're based within and the task they're aiming to complete. So all of those things influence the expectations that a user brings before they interact with a system or a technology. What the user then does is uses that experience to influence how they think the system works. So let's imagine I'm using my new kitchen hob downstairs. I have got an induction hob, but I've never used an induction hob before. In previous houses, I've always had a gas hob, so I've directly lit the flames and understood the relationship between the height of the flame and the heat that's being produced, and therefore the speed that the cooking will take place in. When I got an induction hob, I actually almost did a little bit of training and reading. So I learned about how an induction hob works. And an induction hob works through electricity that creates magnetism, and the magnetic sort of force that comes through the induction hob excites the iron element within the saucepan on top of the induction hob, and that movement within the saucepan creates the heat. So it's a completely different mental model. In a gas hob, the heat comes from the gas flame. In an induction hob, the heat comes from the movement of the metal particles within the base of the saucepan that creates heat, and that movement is created by a magnetic force that's influenced by the electricity that's taken to the hob in the first place. So that's my understanding of how the technology works. I also am influenced by the context. So cooking is not quite a safety critical task, although it can have some safety elements, but the biggest impact of the way in which I use a hob is on the quality of the food that's produced. So I have combined my own knowledge with the information the system presents that influences how I interact with it. But then, of course, I've started to use the system. And what we see here is a very, very effective feedback loop. So as I've learned to use the induction hob in my kitchen, I've learned the appropriate settings to use at different stages in the cooking process. I've learned it's often quite good to put the heat up quite high to heat the pan in advance, and I've learned how quickly responsive the hob is as well, if I need to reduce the heat. In terms of this part of the model, here you can see the role of the designer. The designer has a direct influence on the system image, but very rarely does the designer interact with the user themselves. So the designer's responsibility is to communicate to the user via the system image. And the designer needs to think really carefully here, because the designer might have more expert knowledge than the user. Now, I mean, I've got a chemistry and physics A-level, so I was quite interested in induction hob. And my mental model is probably formed by my understanding of conservation of energy that I learned when I was at school. But the designer of an induction hob shouldn't be assuming that people have advanced level qualifications in chemistry and physics. So what they need to think about is, what feedback do I need to design into the system? How do I communicate to the user the current state of the system and the extent to which the system is working effectively? So that will be influenced by the designer's expectation about how the system is going to be used, the use model, and they will form a design model that influences how the system image is created. And of course, all of this is influenced by who designers think users are and how they'll behave, and their experience and training, but also the context in which they're working. I've given you an example of a commercial product. The challenge with a good commercial product is you want to sell as many items as possible, probably for the highest price you can get away with. If you're developing a system for use in a work-based context, for example, actually the project effect will be very different. It might be about minimizing costs or maximizing ease of use of a system, or addressing some of the technical failures of a previous system. So those factors will influence the way in which a designer designs, and may even influence the expertise amongst this team, because that design team is often more than one person. So what this diagram really does is remind you of the relationship between the designer, the system, and the user. So the reason mental models are so important is that if we assume mental models are things that people bring to their interaction with technologies and systems, they have a very strong influence on the way in which that period of use actually takes place. And therefore, we can think about how we can design to influence mental models. One of the things we also know is it can be very, very difficult to capture an individual's mental model. It's one of those things that we don't tend to consciously be aware of or describe. So we will think about that when it comes to some of the later discussion points as well. And here are some references. The Donald Norman book is particularly helpful if you want to take a look at mental models. So it's a really easy read, and it is worth trying to get hold of that book if you can, and just take a read of that. Thanks.